Excellent. Welcome. This is Newmar's presentation here about Rackmount inverters. My name is Robert Rausch. I'm the Director of Product Management for Newmar, and I will bring you through this. First off, we'll just give a brief agenda here of what we're going to be speaking about today. I'll give a brief introduction to Mission Critical Electronics, MCE, and Newmar itself. Go over some high points about choosing a rack mount inverter, and then highlight some of the Newmar product solutions. So a brief thing about Mission Critical Electronics. We're a platform of distinctive brands and products focusing on industrial, electronic, and electrical applications where durability, reliability, and performance in hostile environments is essential. Solutions vital to mission-critical applications in a variety of industries include public safety, emergency, telecom, network, industrial, marine, specialty vehicles, long haul, and military. We pride ourselves on our technical expertise. Mission-critical engineers use the voice of the customer to ensure they design the right products for ever-evolving and growing markets, working with them to develop the solutions for each product. Quality assurance, when it must work, when it cannot fail. Mission critical electronic brands are the names to be trusted. MCE is exacting quality standards that make its products the recognized industry standard for reliability. Sales and customer support. Mission critical electronics has dedicated sales, customer, and technical support staff available to help customers choose new products or provide support to existing equipment in the field. And fulfillment. Production operations are tailored to provide customers with the shortest lead times while maintaining the strictest quality standards. And here at the bottom of the slide highlights the various companies underneath the Mission Critical Electronics umbrella. Everything from AC, Duracom, Newmar, Perkys, 0RPM, American Battery Charging, Kuzma Electronics, Power Products, and Xantrex cover a wide range of markets and industries, and we're here to help. Briefly, this just gives you a visual representation, just a variety of products that we support and produce ourselves. Everything from DC power systems here in the lower right-hand corner to vehicle charging, inverters, battery chargers for rail, handheld portable radios. So you get really understanding that we do a variety of products in the power realm that support mission critical applications. Briefly about Newmar and some of the other companies. Within Mission Critical Electronics, we're divided into 3 different verticals, one of them being network and industrial. The network and industrial encompasses Newmar, Duracom, ABC, and Power Products. Newmar's been a leading manufacturer of reliable and high-quality communication products for over 50 years, offering an extensive line of AC and DC power supplies. Newmar powers essential equipment for network communications and telecom, public safety, providing solutions for indoor and outdoor applications. Duracom, with over 30 years of experience, offers a complementary product line that provides a variety of offerings from simple desktop units to sophisticated rack mount battery management systems. American Battery Charging focuses mostly on industrial battery chargings for the rail and utilities markets. And Power Products, we do handheld replacement batteries for OEM two-way radios, chargers, accessories, et cetera, et cetera. So just gives you an idea of the type of products that encompasses the network industrial portion of our company. So with that being said, we're going to jump right into rack mount inverters. So first off, what's an inverter? An inverter converts the DC electricity from sources such as batteries or fuel cells to AC electricity. The electricity can be at any required voltage. It can operate AC equipment designed for mains operation or rectified to produce DC to a desired voltage. This is something that's pretty common out there. A lot of telecom sites, a lot of radio sites, wireless, they have a big choice out there. First off is what type of power do they want to operate off of? For a good chunk of the industry, DC voltage is very prevalent, primarily neg 48, but you do see 12 volts, 24 volts, even 125 volts on occasion. Those are pretty common, but there are a large portion of the segment out there that prefer to operate using AC power. And that could be for a variety of reasons. Familiarity, the equipment that they're already they're using, the legacy stuff that's been around forever, may just run off of a plug-in AC power cord. So the preference there is really not as important as making sure that you're operating with something that you're comfortable with, and that's going to give you the performance that you need and the reliability you need. Who benefits from using an inverter? Um, Whether it's land mobile radio operators, broadband providers, WISP service providers, all of these can benefit in a variety of means. Again, it's how comfortable are you with the application, the type of equipment you're running, the type of power levels you're operating at. These all factor into choosing the right source. And if your source happens to be an inverter, or you want to run off of that power source, by all means, we're here to help. So some of the considerations we want to take into account when we're selecting an inverter are, first off, power requirements. Consider the continuous power rating, surge power rating, and input voltage rating. You're going to have a variety of inverters out there that can operate off of a variety of voltages: 12 volts, 24 volts, 48 volts, 125 volts. And they're going to operate at various wattage levels. So one of the things we're going to have to do is first figure out, what are your power requirements, right? So we want to make sure that we've calculated and looked at all the attached equipment that's going to be running off the inverter, and make sure that you select an inverter that can handle the amount of equipment you're using. Depending on the type of inverter you select, the number of outputs, they may have 1, 2, 3, 4 outlet receptacles on there, and you may have to consider adding on an additional power strip or PDU to distribute the power more efficiently across your application. But it's important to understand that we want to make sure we have enough power first and foremost. It's pretty common out there that you do, as best practices, like to consider leaving a little bit of extra. So for example, if your power requirements are exactly 1,000 watts, you may want to consider sizing up to the next wattage available, just to give yourself some margin. Typically, on average, it's about 20% is what we recommend. That's for giving you a little bit of overhead in case you get, let's say you buy a new piece of equipment and it has a slightly higher power requirement, that you have a little bit of extra headroom there so you can expand. Or if you need to add more equipment after the fact, right, you have a little bit of capacity there that you don't have to swap out and bring your site down to be able to switch over to something new. So again, something to consider. You're typically going to see things rated in either wattage or what they call VA, volt amps. For the most part, they're pretty equivalent, with the difference being the power factor between them. There is a number called a power factor. Typically it's 1-to-1, but it can be a slightly different ratio. So you may see some discrepancies between let's say 1,000 watt, and it should say 1,000 VA, but it might be a little less. But for most intents and purposes, working with watts makes it easier for everyone. The next thing we want to look at is efficiency. The efficiency as an inverter is how well it uses the DC power to convert to AC power. The more efficient, the more runtime for your battery bank or whatever DC source that you're providing to your unit. But the other thing to consider when you talk efficiency is that anytime you take one form of energy and convert it to another, whether it's DC to AC, AC to DC, or even DC to DC, you're going to have some losses. And what you typically see that is in heat. So the more efficient, the less heat that's generated, which means that you get less wear and tear on the equipment and better life overall. And you have to have less and less means of managing that heat within your systems. If you've got a big cabinet, or you're in a facility where you have a large AC systems, that may not be a big issue. But for those using an inverter in an enclosed space, or in even enclosure, managing that heat becomes very important. Or say the weather outside. Not all of us are blessed, Southern California, where most days are sunny and 72. A lot of people have heat extremes. They're operating on the high end, they're operating low end, and having an efficient inverter makes your life easier out there in the field. The next thing we want to talk about a bit is battery compatibility. You know, the first and foremost, I'll say it, and it sounds silly, but make sure the batteries you're selecting match the voltage rating on your inverter. You're not going to run a 12-volt battery on a 48-volt inverter. It's just not going to work. So you're going to need a 48-volt battery bank to match up with your 48-volt inverter. Now, that being said, for an inverter on a larger system, you can run it off of batteries, you can run it off of a DC power plant, you can run it off a power supply. All of those will work, and they'll work just fine. It should be noted that if you're going to run it off of batteries, that you're going to have to provide some type of charging system to make sure that your batteries are topped off. Inverters, generally speaking, just do the inversion process, and they don't charge the batteries. So you'll have to make sure that you have some type of, whether it's a battery management system, battery charger, a DC power plant of some sort with its own built-in battery backup. However you manage to go to your application, it will work. Just make sure that everything is compatible in that regard. The second part to consider is if you're going to run off some battery or have some type of battery backup capacity, you'll have to calculate how long you want your batteries to run. And that should be part of the entire system. So if your entire system needs to run for an hour, you need to do a load calculation to figure out exactly how much battery backup you need to support the load for a given period of time, right? So if you need an hour of backup time at 48 volts, you'll have to do the appropriate calculation based on your loads to figure out how big of a battery bank you're going to need to support that application. None of us want to lose connectivity at all, and making sure that you have the right amount of battery backup is important for those applications. Bypass switch. Now this becomes kind of an application specific choice, but it is important to note. Depending on your application, you may or may not require a bypass switch. For an application where it's a small load, let's say 300 or 400 watts of power required, and it's for a piece of equipment that is non-critical, or it's a secondary source or something along those lines where it's not that big of a deal, or the risk to your site is not that important, right? You may not have a bypass switch. You're running, let's say, a legacy piece of equipment. It's a wall wart type of power supply, and you just need it to be able to run. But if it goes down, it's not that big a deal. So you may run it off of a smaller system that's just, doing the basic inversion without any type of bypass switch. But what the bypass switch does is allow you to hook up AC power to your inverter, pass through, and if needed, you can engage the bypass switch if you need to do battery maintenance, if you have a problem with your inverter. That way you don't lose your site while some issue is going on with your piece of equipment. So it really allows you to give you some flexibility and manage some of your risk when you're working with your site. It's not 100% required, but it's something to consider when you're making a selection for the equipment. Alarms. Alarms signal the operator when there's a change to the normal operation of the inverter. I mean, obviously, right? For those of us who've been technicians for a number of years, we've become almost immune to the blinking lights and annoying sounds that happen, but they're important for us, right? It allows us to highlight what's going on with our site, make sure that we can rapidly assess and triage any possible issues and get to the root cause and corrective action as quickly as possible. Alarms can be anything from a simple summary alarm saying, hey, I'm broken, effectively, or up to a more complicated system where it's tied into SNMP, simple network messaging protocol, which is pretty much the common interface in the telecom industry, letting you know that there's an alarm of some sort and even what that alarm may entail. It's becoming more and more common to have this type of application have an alarm be available so that you know exactly what's happening. Unfortunately, in the modern world, every site seems to be about 2 hours away, if not more. And doing a 4-hour round trip for something that is faulting is never a fun trip. But having the alarms, getting there, the information prior to arrival allows us to understand what we're getting ourselves into when we approach the site. Pure sine wave operation. Pure sine wave operation. It's something here in the last number of years where back in the day inverters could have produced a variety of different types of outputs, square waves, triangle waves, um, a modified sine wave. But for the most part, most modern inverters, the ones that we're going to use that need the reliability and quality that we expect for our sites, are going to be pure sine wave operation. But it doesn't hurt to make sure that the spec sheet and the unit itself produces a smooth, repetitive oscillation for a sine wave. There's a lot of equipment out there that can be a bit finicky, and if it doesn't get the right signal in, it won't work correctly. So pure sine wave operation helps alleviate some of those issues and make sure that your equipment is going to operate when you expect it to operate. It also prevents potential damage or malfunctions. It's the standard which we use to choose an inverter. And it best replicates what we're seeing out of an AC wall outlet for the most part. And with those considerations in mind, we're just going to talk briefly here about some of the Newmar offerings when it comes to rack mount inverters and a couple of applications. So for the most part, our first rack mount inverters here, these are our smaller units. They're anywhere between 400 or 800 watts. They come in a variety of voltages, negative 48, 24 volts, and 12 volts, which covers most applications out there. The nice thing about them, they're highly efficient. They offer a single input, standard 19-inch rack mount, power switch, and resettable fuses. Generally accepted basic protections here: inverse, reverse polarity, over voltage, short circuit, and overload protections. These are really designed for those sites that just need a little bit of AC power, right? For example, you're powering a legacy router or a switch of some sort where it's maybe a wall wart or receptacle. But most of your other site may be running off of neg 48, for example. This gives you a little bit of AC power. And this particular model comes with 3 receptacles in the back and then 1 in the front, which I like to refer to as the convenience receptacle for those who visit a site. For most of the time, all of the receptacles are generally accounted for. So when you show up and your cell phone or your laptop is on 5% charge, having something on the front where you can charge that up while you're doing your maintenance or you're walking through and fixing your equipment is pretty helpful. But these are really geared for those sites that just need a little bit of power, something there that they can work with, and go from there. Our newest rack mount inverters are these. So we offer 3 different models and a couple of different power levels. We offer neg 48, a pair of neg 48 inverters at 1600 watts and 2400 watts, and 125 volt inverter at 1600 watts. These ones are a big step up. The previous ones were 1U, didn't take up a lot of space. These ones are 2U, take a little bit more space. Both offer true sine wave outputs, wide operating temperature range, multiple receptacles, standard 19-inch rack mounts, built-in protections. This one actually has forced air cooling. So as we're, because of the power levels involved here, we're operating at 16 and up to 2400 watts. These actually have built-in forced air cooling to keep the heat down and allow your equipment to last longer, operate more comfortably in your environment, even if it's in a small enclosure. It'll be cool there. Now, this particular model has Form C contacts. It provides that summary alarm saying, "Hey, there's something here." It gives you a couple of different options here for a summary one and a few over temperature or alarms. But it gives you just enough alarming here to understand what's happening with your systems. These are best used for when you've got a heavy amount of equipment that you need to plug in and operate for a longer period of time, or your site may be primarily AC based. This will provide the enough power for you to keep your units up and running nice and smooth over time. In summary, I mean, there's a number of key points that we would like to go over. The 6 key points: power, efficiency, battery, bypass, alarm, and sine wave operation, are what we use to provide that guidance to our customers and to you about what's the best choice for a rack mount inverter. And addressing these key points will enable you to select the right inverter for your application. In this case here, I mean, we're more than happy to sit down with you if you've got any questions and go over that. Again, by all means, please contact our partners here at Tesco or myself here through the my contact information here as well. We'd be more than happy to discuss any applications with your inverters. And I thank you for your time.